All right, today we're diving into something pretty radical, a new framework called Digital Fabrica Theory, or DFT for short. It's a total reimagining of how we build decentralized systems, and I mean starting from the absolute ground floor. So let's get right into it.
Just think about this for a second. What if our digital reality, where we do business, govern communities, and live our lives, wasn't just based on code that can be buggy or manipulated? What if it was woven from the very fabric of mathematical truth, something as fundamental and unbreakable as the laws of physics? That's really the core promise of DFT.
And you can really see the difference here. I mean, current Web 3.0 systems are amazing, but they're hitting a brick wall. They can't scale without breaking, they're looking pretty shaky against future quantum computers, and let's be honest, their governance can often just turn into a who has the most money game. DFT looks at each of these problems and says, we're not going to patch this, we're going to solve it at the mathematical root.
So, what is the real problem that DFT is trying to fix? Well, it argues the issue isn't just about code or algorithms. It's actually much deeper. It's philosophical.
Here's the core idea. Most decentralized networks today are built on a foundation that's, frankly, a bit fragile. Their logic isn't tied to any deep, unchangeable truth. It's like trying to build a massive skyscraper on sand. DFT calls this missing piece an ontological anchor, which is just a fancy way of saying a connection to a provable, fundamental reality. Without that anchor, the whole thing is always at risk of falling apart.
So, DFT's solution is to, build that bedrock first. It sets out to create a complete, multidimensional map of reality before even thinking about code.
And that map has a name, the Canonical Layered Ontology, or CLOMS. Seriously, think of it like the laws of physics for a new digital universe. It's a 14-layer blueprint that defines absolutely everything, from ethics to economics, making sure the entire system is built on pure, consistent, unshakable logic.
And this is where it gets really wild. Just look at the scope of this vision. The CLOMS hierarchy starts at layer 0, the prime ethical core. That's the system's ultimate source of truth. And it goes all the way up to layer 14, the infinity kernel, which handles things like consciousness and agency. Every single thing has its own dedicated layer. Logic, policy, governance, it's a complete map of existence.
Okay, let's look at a real example so this doesn't feel so abstract. Down at layer 2, we have something called topological form. Here, policies aren't just words in a document that you can argue about. Nope, they are encoded as mathematical knots. And the only way to change a policy is to transform it into another valid knot, a process that can be proven with an equation. This makes your governance literally tamper-proof.
Now here's a problem we see all the time, right? When your voting power is tied directly to how many coins you own, the richest people can just buy control of the entire network. That's a plutocracy, and it completely defeats the purpose of decentralization.
DFT has this beautiful, elegant solution at layer 8. It uses the famous Riemann zeta function, the one from pure mathematics, and applies it to voting power. What that does in simple terms is it creates diminishing returns. So the more you own, the less and less additional influence each new token gives you. It's a mathematical guarantee against an oligarchy.
Okay, so we have this mind-blowing 14-dimensional blueprint. But how do you actually build something with it? How do you go from this abstract map to a real working system? How do you weave the fabric?
The process is actually, believe it or not, pretty simple at its core. You start with one basic building block, called the hyperhexanode. Then, you connect these nodes using smart contracts, which are the fibers. And as you weave these fibers together, they form this complex, super resilient, and intelligent digital fabric. That fabric is the decentralized system.
And what's so cool is that each of these connecting fibers isn't just a simple link. It's a dynamic vector that has real measurable properties. Things like tension, how much load it's under, elasticity, how adaptable it is, and density, how much data it's carrying. The system knows this for every single connection, which means the whole fabric can intelligently organize itself, balance loads, and even heal itself.
And that ability to self-organize is the key to its power. It lets the whole fabric scale up massively, but in a way that's incredibly stable. Instead of just adding things in a straight line until it breaks, it uses a principle from fractal geometry to grow outwards in this really structured, super efficient way so it never collapses under its own weight.
The secret sauce to that stable growth is this number, about 1.58. This comes from fractal math, and it's actually related to the famous golden ratio. You can think of it as the perfect sweet spot for growth. It's the ideal balance, not too crowded, not too sparse. By targeting this exact value, the network can grow way faster than older systems while staying perfectly balanced and efficient.
Okay, all this advanced math is amazing, but let's bring it back to Earth. What does this actually mean for the real world? How does all this theory actually create a tangible impact?
This quote from the project's master blueprint really says it all. The goal isn't just to publish a cool paper. It's to give people the tools they need to actually build these next-generation networks, systems that are quantum-proof, fair, and scalable right out of the box.
And the potential here is just vast. Imagine DeFi, where you can swap assets between any chain without having to worry about hacks, or a supply chain where you know your products are ethically sourced because the code itself guarantees it. You could even build AI systems where fairness isn't just a hopeful goal, it's a mathematical property of the network itself.
And look, this isn't just some sci-fi dream. There's a clear roadmap here. Year 1 is about getting the core framework and tools built. Year 2 is all about getting it into the hands of institutions for real-world use. And the end goal? A totally self-sustaining ecosystem built on these incredible principles.
So, what are the big things to remember here? First, DFT is about moving our digital world from a foundation of fragile code to one of solid, provable math. Second, that 14-dimensional blueprint gives us a complete structure for building fair and scalable systems from scratch. And finally, this isn't just a small step forward. It's a whole new way of thinking about how we build our digital reality.
Which really just leaves us with one big question. In a world that is so desperately searching for digital trust, for real security, for genuine fairness, could a framework built on an ontological blueprint of mathematical truth be the future we've been waiting for? Is this the architecture that finally delivers true digital sovereignty?